and a little bit about improving. It is we have user group service space available. If you're interested in hosting a user group, let us know. And we have 2 training rooms that are both available, so we can host a couple user groups a night, and we can even host 3 if the need arises. We have user groups like Pre-Code Camp, Java user group, .NET user group, Side Project Society, Linux user group, and Use and Product community. And they're all quite vibrant communities. And we're also hiring right now. We're looking to grow the office this year. .NET developers, Java developers, front-end developers, Agile coaches, and DevOps engineers. We have all those on our team already, but we are looking to hire more. So let me know if you are interested. And also, if you want to learn more about Agile and about Scrum and about Kanban, we do offer trainings. We are the largest provider of Scrum.org training in North America, which is quite impressive if you ask me. But I've gone through some of the training. It's really great. Our presenters are top notch, and they're all a professional Scrum Master, a professional Scrum Trainer certified as well. So you'll be working with very qualified individuals if you decide to pursue Scrum training from us. If you were interested, you can go to improving.com/training, I think, to see the full schedule. A lot of our training actually happens online now, via interactive online courses that are, sorry, not interactive online, but it's human that's actually presenting the course, and so you can ask some questions, and it's a very interactive course. It's a lot of fun, learn a lot. It's really, really neat stuff. And then also, if you could please take a moment to sign in, I would really, really appreciate it. This will help Use Java to continue to be sponsored by Improving. It certainly helps. So again, if you could take just a minute to fill this out, I would really, really appreciate it. And certainly, last but not least, once you get done filling out the registration form, Scott has a door prize link. So if you could go ahead and whenever you're ready, go ahead and take a snap of that as well, and you can sign up to win some door prizes. What do we have for him this month, Scott?
Well, we have the IntelliJ, the license, 1-year license for any IntelliJ product. Almost any.
Mm-hmm.
We also have the
Sonograph,
right, the sonograph, and the
Webicator,
and the Webicator.
Okay, great, very good.
I'm working on some other things.
No,
so we'll see what we can.
Can you talk about those or not?
Sure. I mean, I'm
built some excitement.
Sure. So I'm talking to Manning to try and get to like a free ebook.
Oh,
and,
nice, very cool.
A couple other publishers as well.
Very exciting. Very exciting. Great. Well, fantastic. Okay. Well, I will stop sharing. Everybody got this QR code as well. Make sure you get it so you can win, or so you might win. All right. I will stop sharing and hand this over to Gerrit. Thank you so much, Gerrit. Appreciate you coming out all this way.
Okay, now I should be, you should hear me. I hope so.
I'll turn my speaker back on.
Yeah, okay. Does it work? Okay.
You're echoing.
All right. Perfect. Yeah, first of all, thanks for having me. I think we talked about it. When was it? It's some what? What was it?
Texas or whatever it was.
Ah, in JConf in Dallas, right? Last year.
that name, Dev Texas.
Dev Texas, yeah, sounds good. So yeah, and then we set it up, and today it's the day. So this is all about security. Some people might remember this. Who knows the movie Wargames?
Can you share your screen?
Oh, isn't it?
On Zoom.
Yeah. Oh, okay. Wait. Share. This one. Share. And just a second.
Noise.
And go. Okay.
Excellent.
Here we go. Okay, so yeah, this is not related to the movie Wargames, and it's also not related to Spy versus Spy. I don't know if you know that, but I like that because when I grew up, Spy versus Spy was this thing for me. And Wargames, of course, was one of the movies, right? So but I just liked it. So that's the reason. So totally unrelated to the topic. Yeah, Java vulnerabilities and why you should care. So I guess all of you are Java developers. That's good. Anybody in the security area here? Okay, even better.
We all are, whether we know it or not.
Yeah, so where is my... Yeah, my name is Gerrit Grunwald. I'm working for Azure, as you can see. We do JVMs. I also have a Java user group in Germany. And I just can repeat what Jim said, just keep coming, right? It should be more people here. Yes, exactly. So it's a good thing. Just go there. It's absolutely cool. Yeah, I'm a Java developer. I'm not a security expert, not at all. But in November 2021, we all know what happened. This happened. Who was affected? Someone here in the room? Yeah. Most of the people somehow have been affected. And for me, the biggest impact was we have something in Germany, which is it's a daily news show, right? And this is very old. I think it started in directly after World War II. So it's the news show, right? So it's every evening. This is the news. And in this news, they reported about that. That was the first time I ever saw something like this on the TV. I was like, wow, that means this is really huge, right? Because otherwise they won't report it. So that made me think. I was like, okay. And I thought about, I have to look into security because to be honest, before this happened, I never did. For me, it was like, I write the code, I throw it over the wall, and then the DevOps people will take care about it, right? Deployment, and I don't care. Security, not my problem, right? So I'm here for writing code. And so I looked into this stuff and figured out that the software landscape changed dramatically from the day when I started coding. So I'm from 1969. So I'm 55 now. When I started coding, that was in 1982. But I was quite young there. And then I grew up with this. Huh?
You're using punch cards at the time?
No, no, not that old. But it was really like, it was the time of home computers and all that. So I started coding at that time and it was totally different. And then I realized I have to really to look at it. And I figured out that most of the code, right, that we use today is open source. I guess everybody can agree. Without open source, this world wouldn't work as it works today, right? So distributed source code management systems are the standard. We have them everywhere, right? And we have automated builds by CI/CD systems, right? So we don't build the stuff like when I was starting my first jobs, we built the things on one machine and then we had to stop everything, build it, and then copy stuff around. There haven't been any source code systems. We copied folders and renamed them and stuff like that. So there's, yeah, totally different thing. Artifacts are hosted in repositories somewhere and we run on public networks because, like I said, when I grew up, there have been some networks, but it was very hard to get in. And usually that was only in banks and insurance companies and whatever, big industrial companies, but not for everyone. Everything is accessible via browsers or APIs these days, and everything is connected, right? Which is partly a good thing, but it comes with lots of problems, right? And so we have a whole software supply chain in the meantime, which is completely different from when I started thinking about coding. I never thought about this stuff, right? It was all about the code itself, but never about the whole thing that is surrounded. Yeah.
Smart devices.
Yeah, exactly. Right. So it's really, yeah. So we don't have full control over the source code anymore. And that's one of the biggest differences that I see. Because when I started coding in the company I worked for the first time, everything that we used have been written by ourselves. So it was our code completely. No open source software, nothing. So we really coded everything. And this is today totally different. Usually you use all these frameworks and use all the libraries, and then you add some business logic specifically for your company. This is the, let's say, this is the code that you really write, but most of the code that you use is written by other people. You don't really have it under control, right? So, and before we start, we have to look into some definitions, because this is something, and you US guys are really crazy with all these acronyms. And if you're not from the US, right, like me from Germany, it's crazy. If you attend meetings, people just throw these acronyms everywhere, and you're like, what the hell? I have no idea what it means. So in the security area, let's take a look at something. So first of all, there's the so-called NVD, which is the National Vulnerability Database, right? And this is a database that it was created to host all kinds of vulnerabilities in software, in hardware, whatever, right? So they keep all this in this database, and you can access it here, nvd.nist.gov, right? It's in the US, but everybody can access it worldwide. And you can, they even have an API, and you can apply for an API key and they give it to you, and then you can access it from your code, for example. I also wrote a tool that just accesses the NVD, gets some data out of it. So the protocol, this SCAP, Security Content Automation Protocol, nice, not to work with, but yeah. So it's really like strange formats. It works, but takes some time to get used to it. So this is the place where we store the information about vulnerabilities, which is nice that we have this central place. But now we have to define them. And we start with weaknesses, and there's the CWE, Common Weakness Enumeration. And this is like a community developed list of software and hardware weaknesses. Doesn't mean that there are vulnerabilities yet. So it's, you develop something and you, it might not be, there might be a weakness here, right? So there's no exploit, there's no vulnerability yet, but you can express yourself and say, I think this might be a problem, but I'm not sure yet. So you can put it into this CWE, it gets an ID, and then you can look them up at cwe.mitri.org. And then you will find a huge list there of all kinds of weaknesses. And it's not a bad thing. It's just in more like an informal type, right? So you can look stuff up. You will find all kinds of weaknesses there. It's interesting. That's okay. That's the first step in this whole chain, right?
I do wish that more, well, I think revisit later, but like you'll have these CVEs that are 9.8, but there's not an exploit.
Yeah.
Okay, what am I?
But we come to that. We come to that because that's the next step. This
Yeah.
is CWE, right? This is weaknesses. No vulnerability yet. And then there's the so-called CVE, which is the common vulnerability and exposure. So that means there might have been a weakness and someone figured out, oh, there is a vulnerability here, right? So then you can inform the NVD and say, I found something. You have to prove it. You have to send in some code, and it's some kind of process which is defined. And then the CVE program mission is to identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. So that means you found a vulnerability, you mention it to them, and then it will get an ID. And Log4Shell, as we know it, as a developer, in the security space, this is CVE 2021, and then 44,228, which is just a continuous number, right, for each year. They start a new one. And this is the year. And then this is how the IDs look like, right? And this is how they are used. And if you talk to security people, they know this. And they don't know Log4Shell. They don't care. They know this code exactly because they work with that all the time.
there like another vulnerability found almost immediately after this one?
Oh,
Of
you
one-
would be surprised how many vulnerabilities there are.
like, today.
Oh yeah, there have
Another one
been.
immediately following.
Yeah. There have been lots
Right
of them.
away.
Yeah. It's, and if you follow that, you will find that there are really a lot of them, and we will come to this. So
So can I also assume this one is the most like severe, like once you get the CVE number, that means that's a.
patience. We will come to this because now we have the CWE, now we have the CVE. That means this is the vulnerability. And this is how it's stored in the in the NVD. You see, this is the nvd.nis.gov vulnerability detail, and then you see the CVE ID for log4shell. And they will tell you this is the text. You don't have to read through the text, because what it in principle says is this is the versions that have been affected by the CVE, right? Then this is the vulnerability itself. So they describe it to you. What is the problem here? And then they also give you a description from which version to which version there was the problem, then it was fixed, and so on and so on. All this information can be found in the NVD. Okay, that's all cool. So now we know we have weaknesses, we have vulnerabilities. But if you have vulnerabilities, you somehow have to score them, right? Otherwise, it doesn't make sense, because some of them are really harmful, others are not. So, So then they came up with this idea, oh, there's the CVSS, another acronym, Common Vulnerability Severity Score, which is already a little bit older, and the security people are not, it's like they don't really see this as the de facto standard anymore. So it was quite good, but it's not that well established anymore. So if you talk to security people, they say, yeah, it has a score of whatever, but, and I will explain why. So when they started with CVSS 1.0, but the 2.0 was the first one that came with the scoring. And they started with low, medium, high. And it was from 0 to 10. And you might already see the problem. 0 is low. How can a vulnerability of score 0 already be low, right? It doesn't really make sense, because 0 is 0, right? But this was the case, and a lot of these CVEs that you found in the NVD still have the CVSS 2.0 scoring, right? And then after that, they came out with CVSS 3.0, and in the meantime, it's 4.1, I guess, already, but the scoring system stayed the same. And you see now, 0 is none, right? And then it starts with 0.1, and now we have low, medium, high, and critical. So they splitted the high area in high and critical for this stuff. And to get a better overview, you see CVSS 2.0 is on top, and then CVSS 3.plus, whatever it is now, 4.1, is, you see that the high was split in 2 groups, right? So now we also have an additional critical part, which is really, really critical, right? Because 7.0 in the old scoring was high, would be the same as 10. And this is not the best thing. So they decided we have to do another category, which is critical here. And the newer ones always come with the CVSS 3 scoring. And you will find a lot of them, they have both. So that means it is important when you take a look at the score of a CVE, which one is it? Is it 2.0 or is it 3.0, right? Because it makes a difference, specifically for the very critical ones, right? So if we take a look at log4shell, CVSS score 2 was 9.3, high, but in CVSS 3, it was critical. It was the worst that can happen, right? It has also the biggest impact that we ever saw so far, because log4j is used everywhere. And yeah, that was really huge. Okay, so that means we now have the weaknesses, the vulnerabilities, the database, and we have a scoring system, which is nice. But now the problem is, yeah, okay, we have a vulnerability, it has a score. Is it a problem? Is there an exploit? That's the next question. Because just because we have a score and you use that library doesn't mean someone ever exploited this vulnerability, right? And therefore, there's another one, which is a KEV, which is the known exploited vulnerabilities. That means there's a catalog, which is freely available, that only hosts all the CVEs where we know there have been exploits. This is the very important stuff, because you can look it up here. It's by the CISA, and it's the Cybersecurity and Infrastructure Security Agency, right? And they maintain this catalog, and it will be updated, I think, once a day or maybe even more. You can look it up here. Like I said, it's freely available. I think it's a JSON format you can just download. And then that means it contains, again, it's all based on the CVE ID. And then it will only contain CVE IDs where we know there have been exploits. That means if you take a look at the CVEs that you found in your software, and then you check if some of them are in this KEV catalog, then it means, oh, these ones are the ones you really should take a look at, because we know there are exploits out there, okay? That's the KEV. And this is the reason why the CVSS score alone doesn't really make sense anymore, because once you have the score, for example, log4shell will always be 10. They will never change it. This is the problem with the scoring. So even if it's 20 years old, it will still be, oh, this was one of the worst ones, because maybe in the future, nobody will even use log4j anymore, but this is still marked as 10. And this is one of the problems with the CVSS scoring. This one is way better on the KEV because it contains only the ones where we know there have been exploits, right? Which is good, but that was not enough. They came up with another idea, which is EPSS, right? You see what I'm going to, where I'm going to, right? It's all these acronyms. If you have no idea, it's just like, wow, what does it mean? This is exploit prediction scoring system. This is based on AI. This is the newest one. So what they do now, they try to figure out by using AI models and all the data that they have in the NVD database to figure out which CVEs might be exploited within the next 30 days. That's the idea, right? So that means they check, and I think this will be updated every 3 minutes. So what they do is they check all the database, all the CVEs, and they try to figure out the probability of which CVEs might be attacked or exploited within the next 30 days. That's the idea. Then they give you a list with the probability, right, of all these CVEs. That means you can take a look and say, oh, we have this one, and the probability that it will be exploited is maybe by 99%. So we maybe should fix this first, because there's a huge probability that it will be exploited in the future. But this is quite new. So I think they started maybe 2 years ago with this project, but it's quite okay. So it's absolutely worth taking a look at it. So why do I mention that at all? So usually how it works is you have your application and you have a security scanner, should have one, and they scan your code base and they tell you, oh, this is the list of CVEs you have to work on, and they tell you the CVSS score. What the security people have to do then, they get these lists and they have to go through each of them and check them, right? And lots of them might be false positives, because that means, yes, the CVE scanner found it, it was never used, or there is no exploit available, right? So, and that means it's a lot of work. And this is one of the reasons why they came up with these ideas like the KEV, like the EPSS, to help you prioritizing stuff. Okay, so how they are connected, I tried to explain it already. So it starts with a weakness that becomes a CWE, and then there might be a vulnerability based on the weakness. Sometimes in the CVEs, you find the CWE ID linked to it, right? So because there might be a weakness and the vulnerability is using this weakness to get into the code or whatever. So this is then the CVE with the CVSS, which is in the NVD database. And then from there might be an exploit, and they will try to figure that out with the KEVs. They will list all the exploited ones in the KEV. And if there was an actual attack, and they try to predict it with the EPSS, right? So this is more or less how they are related to each other. And then in the end, you will have a patch that fixes the problem. So this is, I hope that's more or less clear, but you see all these different acronyms. If you have no idea, then it's really hard to understand what it means. Question is Java secure? So now the big question, did you ever ask yourself if the JDK, the code in the JDK is secure?
course, it was designed to be secure.
Yeah. You just download it from the internet, right? Nice. And you assume it works, right? Of course. And you have no idea if it was scanned or not. So you just trust. This is how it works these days. We just trust. Oh, it's from Oracle. Yeah, no problem. Of course, they make sure it works. Well, this is some kind of a problem, right? But there is a so-called OpenJDK vulnerability group. And this group is it's a group of a private form of trusted members of the OpenJDK community. So that means even if you are the security expert, you can't just go there and say, yeah, I would like to be a member of the group. Then they might say no. They pick the people that they would like to have in their group. And they receive and review reports of vulnerabilities in the OpenJDK code base. So that means if you find a CV, or no, you find a problem in the code base of the JDK, then there's a very specific process how you can tell these people about this vulnerability. And this is not like, oh, I found something, this is the problem. It's like you write them, then they send you a code, right, to encrypt your data. Then you encrypt the data, send it back. So it's back and forth with encryption to make sure that nobody can really get that. Because if this is really a vulnerability, then you better don't talk about it because everybody might be affected. So the procedure is written down on somewhere on the OpenJDK page, how it works. And then you have to also send in some code that proves the problem that you found, right? So then they will start working on that. They collaborate on fixing the issues. They don't actually fix the issues themselves, right? So they just keep track of all this stuff and manage how to do it. Usually this is fixed by OpenJDK committers or by companies they are committers, something like that. And then they coordinate the release of these fixes, right? And they maintain a list of CVE patched for each release. And I will come to that because this is something specific. They track CVEs by component. So who's using JDK 8 here in the room? Okay, everybody's above JDK 8. That means we use a modular JDK. And that means not everybody is using every module. So what they do is they track CVEs by the module because, and I will come to that also, you can design your own runtime only with the modules that your application needs. That means if you have a CVE, let's say in the Corba module, which is not available anymore, but let's say there is one, or the XML module, right? And you don't use it, or desktop is also a module, and you don't use desktop, then you don't care, right? You are not affected. And this is the reason why they do it. So they don't put it in like, oh, JDK 21 has a problem, but they tell you JDK 21, this module, there was a CVE in this version, and we will come to this. So they discuss OpenJDK security related issues, and they do not actively test the OpenJDK source code. This is done by the companies who do the distributions, right? And this is something else that I have to mention because people always mess it up. If someone asks you, what version of OpenJDK do you use? Or what do you use? Which Java version? And most of the people say, oh, OpenJDK. And then I have to say, this is wrong. You can't use OpenJDK. OpenJDK is the name of the source code in GitHub. This is OpenJDK. And everybody who builds this source code creates a so-called distribution. And this is what you use, right? And most of the people have no idea which distribution they use, but it makes a difference. But this is not part of this this session. But if you really have to think about, do I use Corrado? Do I use Zulu? Do I use Microsoft JDK, Oracle JDK? There's SAP machine. There are 20 different distributions in the field, and they come with different features. And there's also something that is called the TCK, which is the Technology Compatibility Kit. And that makes sure that if you fulfill all the tests in that test suite, then it means you can exchange JDKs without having a problem. And not all the distributions do that. So for example, there is a distribution from Alibaba, you might know in China, it's very big. And they don't have the TCK for JDK 11 and above. So that means if you use that, your code might break just because of the JDK, right? So that's the reason why you need to know which distribution you use. But like I said, this is not part of this session. So they do not test it. This is done by the distributions, right? So for example, if we create a new distribution of Zulu, which is all built of OpenJDK, then we test the source code. We make sure that it's secure. All right. And then what they do is it's the so-called OpenJDK vulnerability advisories. And this is exactly what I mentioned already. It's 4 times a year. With every update, you get them. And they give you a list of the, or they describe the severity, the area, and the affected versions, right? And you will find them here, openjdk.org, groups, vulnerability advisories. There you can look them up. I can provide the slides, so you don't have to really take screenshots or write something down, because then you can look it up yourself. So what it looks like is this. This was for JDK 2101, 1709. You see there is the list. And this is the advisory. You see there are the CVE IDs. This is the modules that have been affected. This is the CVSS score. And then you see which versions have been affected. For example, the first one was in security libs, Java security, and only 17 was affected, not the other ones. Right? So, and this kind of things will be, this is publicly available with every update. But did you ever read it? Oh, see, people don't care. What's that? Yeah, exactly. Right. So, but this could be quite useful, especially if you have some audit in your company, right? Security audits or something, then you better know what version you have and what are the problems and stuff like this. And if you use, let's say, we will come to that. This is another slide for this one. But this is the advisories, and you get them with every update. Directly with the update, you will get this list, and then you can look it up. And that leads me to the Java release cycle, because that changed a lot from former days. This was the old cycle. Took forever to get JDK 7. I remember these days. And we had a big party that finally there was JDK 7, which came with some new features, but it was 4.5 years. Right? And then it took another 3 years until we got JDK 8. And that was a big one, right? This was really a really big and good release. And that was the first one that was named LTS, long-term support version. Today, Oracle said there is no LTS. Well, if they offer a version where they offer long-time support, then this is a long-time support version, right? So this is the LTS. Because usually, and we will see that on the next slide, this is a new release cadence. And now we have every 6 months, we have a release. And then we see the black ones are the so-called long-term support versions. And they started with 8. And then again, it took 3 years from 11 to 17. And they figured out, that was too long, because we have 5 STS short-term support versions in there, and then the next long-term support version. What it means is, for the black ones, you get support for 8 years or longer. For the white ones, you get support for 6 months. So if you, for example, go to JDK 12, because there was, for example, there was JPackage, came with JDK 12. It's a tool to create native packages, or not really native. It's like, it's a wrapper.
Bundle.
Yeah, so bundle it and you have a native starter, right? It looks like and feels like a native app, but what it does, it's a native application that starts your job, right? So that came with JDK 12. And I was in a project where we needed that. So we used JDK 12. 6 months later, so we had JDK 12.01, 12.02, and that's it. No more security updates for JDK 12, because then we got JDK 13. That means if you would like to stay secure, and you better do if you are in a project, we had to switch to JDK 13. And then the same for JDK 14 and JDK 15 and 16. And finally, we went to JDK 17, and then we could stick to 17 because that was the long-term support version. Means you get updates for a long time. So that's the problem. If you go to these short-term support versions, yes, you might get the new features, but you have to change the JDK every 6 months. And that's really a lot of work, especially for big companies. They're really hesitating to switch from JDK versions to others. So I know even companies, they don't even use the LTS. They only use only the second LTS. So they switch from 11 to 21 and they leave out 17. Sometimes I also found companies that do that. So don't ask me why. And there are also distributions that only offer LTS releases. So you might find, for example, Microsoft, They offer 11, 17, 21. They don't offer all the ones in between. So that means if you would like to have the latest features, not every distribution offers that.
It's a lot of work for them to do.
Yeah, I can tell you it's a lot of work to do that because it takes us more than a week to build one release.
Wow.
And this is a whole team working on that because the main problem here is I already mentioned that there's a TCK which describes it's a test suite which is more than 200,000 tests for JDK11 or something like that. And you have to pass all the tests on each operating system, on each hardware to make sure that you get it, right? And that sounds like, yeah, okay, how hard could it be? Well, things are tested like Blu-ray players, CD-ROMs, printers, sound cards. All this stuff you have to have in your machines and test it because these tests cover everything that can Java do.
Even like Kindle devices.
Which is it's huge. It's a lot of stuff you have to do. We have our own hardware park just for testing this stuff.
Hardware park.
Yeah, you need that. You need all the different you need all the different hardware architectures, right? You need the Intel CPUs, you need the ARM CPUs, you need the different operating systems that you support. And then you have to keep them up to date and you have to run the tests on all these systems to make sure that you pass the TCK. That takes some time. Okay, now we're in a 2-year cycle between the long-term support versions, and we will see 25 this year in September, which is the next long-term support version. And just as an example, I think JDK 8 still has support to 2030, and 11, it's, I think, 2029, and 17 is again 2031 or something like this. And this will change over time. So because with 8, it changed a couple of times because it was so popular. And Oracle decided to, we support it longer and longer and longer because just companies use it and they like it, right? And it's sometimes for them really hard to switch from 8 to 11 because lots of stuff changed in between. So, and they are really hesitating to do this switch. And the longer the wait, the more critical it will be. Okay. The question is, we talk about security. Why does this has an impact on security? That we have so many releases now. Well, that's pretty simple. This is the number of features that came with JDK 8 and JDK 9, right? 91 features in JDK 9. This is mainly because we got the module system here. But 56 features in JDK 8, this is a lot. If you think about it, you have to make sure you add 56 new features to Java, and you have to make sure that everything works and is secure. That's a lot of work. If we take a look at the new release cadence, that's the number of features. And you see that this is a difference, right? So it's way easier, and that means less features per release means less potential vulnerabilities per release, because if they just have to check 5 new features, it's way easier to make them secure instead of 56, right? So that's one of the reasons. So this is the new release cadence, and this has an effect on security, definitely. So it gets better. And I can prove that because we will see that later on. Java updates, yeah, that's an interesting one because people usually have no idea. Does anybody know what a CPU is? Yes, oh, wow. Yeah, it says it, right? But what is a CPU? Well, I will explain it to you. A CPU only contains fixes for vulnerabilities and critical issues, and that's it. That's the whole thing. It's absolutely safe to run that in production. Does someone know what a PSU is? I mean, without reading it, it's patch set update. What does it mean? No idea. This is the stuff that you download from the internet. The other one you can't. And I will tell you the difference. This one is a superset of the CPU plus, so it means it contains the fixes for the vulnerabilities, also for the critical issues, but then, also fixes for non-critical issues. And the worst part is they add features. Not big ones, not something like Loom, small ones. It's stuff like, oh, look, we have this nice little feature here. Let's add it to the update. No problem. It sounds like there is no problem, but there is, in fact, a problem. So if we compare it, 1702 you see on top there is the PSU that contains the CPU, right? And on the bottom, we just see the CPU, just the critical patch update. So this is in January, 1702 came out, all good. Then the next one is in April, and you see what happens. The PSU on top gets the fixes and features, right? The CPU is based on the last PSU and only fix everything that was found in this 3 months in the PSU and fix it. And that's the next CPU. So why are we doing that? This is a lot of work. The reason is, this is the stuff you download from the internet, your companies, and you run it for 3 months in production, and you find problems. We only fix the problems, and then we create a CPU out of that one. That means this one is more stable than that one. And this one is feature-wise behind this one, because it's 3 months behind, but it's more secure, right? So nobody knows about it, because this is only 2 companies created. It's Oracle and Azure. It's a lot of work because we have to do everything twice. We run the whole thing again, but we only fix the issues and don't add the features. Yeah.
You mentioned that the PSU is downloaded.
Yeah, the PSU.
So then this April release
Mhm.
is only CPU. It
Yeah.
doesn't have the new feature. It has the critical patch in it. But
This
it's
one
downloaded.
only has the fixes, the
Right.
CPU, and this one has the fixes from the last one, but also get new features.
Okay.
And that's the problem, and minor fixes too. So that means stuff that was, yeah, let's fix it. Or, oh, there is this little feature, let's add it. It doesn't sound like a big problem, and usually it isn't, but we have some examples where we can show that in fact it is a problem sometimes. That's the main reason why we do all this. There must be a reason, right? We wouldn't do it if there wouldn't be a reason, and Oracle does the same. They also offer CPU updates, and I think I'm not sure, Bellsoft might also offer it. But usually what happens is this is not for free, you have to pay for it. And sometimes it's the case that especially banks or every bigger company that handles critical data, like private data, especially in Europe, because we have different laws with privacy, they have to do that. They have to use these ones. So the next one is then in July, same thing happens, right? And then the last one is in October, right? And it's always the same procedure. The CPU is always 3 months feature-wise behind the PSU, even if they have the same number. Because they are based on the last PSU. Okay, so why they matter? In PSU 8U252, right? There was a change. This is one of these little features, and this change prevented Hadoop cluster and Solr from running. And this had a huge impact because that means you have the latest security update and your system crash, right? You can't use it anymore. So what should you do? You have to go back to the former one, or you have the CPU, and then you might remember these numbers, because when Oracle JDK still was free, they had both of them available for download, and I never knew what's the difference, right? You see 252, 251, what does it mean? Now I know. So this is a CPU update, and this was based on the former PSU, right? And only fixed the issues, and it didn't came with this little change. And that worked. So this is just one of the examples. We have more of them.
Till the next CPU is released that incorporates the PSU.
But then it only contains the fixes, right? Was already, we only fixed, and this thing was fixed in the next one.
Oh, what? Okay.
Yeah. So this is the thing, right? So the CPU fixes only the issues from the PSUs, and that was one of the issues.
Okay.
But you won't get a quick fix for that one. So that means if you run Solr or Hadoop cluster, yeah, that's it. Oh, you have to go back to 242, right? If you don't pay for it, that's the whole point, right? And that means you are open for vulnerabilities because this one has open CVEs that have been fixed in that one. So and this is the whole thing, right? This is why it makes sense if you work with sensible data, then it makes sense to take a look at the CPU updates. But like I said, these are not for free, but there is a reason for it because there's lots of work to do that. Okay. So the next thing, and this is quite interesting because we as developers, we are lazy. right? And I found myself before I worked at Azure, I did the same. I installed JDK8 and I kept it. Updating, yeah. Maybe I updated at one point, but yeah, usually I just installed it once and then used it for all the time I worked with that. So just let me give you an idea about what happens if you stick to an older version of JDK. Let's say this is the chart for JDK8. So if you stick to JDK 8.0, you're open for 476 CVEs in the meantime, right? And you see there are some criticals. This is the CVSS score here. Lots of mediums, some green ones, which is low, and some high, and then a few of them are really critical. And you see it decreases, right? If you go to the newer versions, you have less and less open for vulnerabilities. This is JDK8, which is quite old. It's like 10 or 11 years old in the meantime. But you see, this stuff piles up if you don't change it, right? So if you go to newer JDKs, let's say, take a look at 11. 11 still 153 CVEs if you just stick to 11.0, if you don't update. And that's a lot, right? There are just a few critical ones, but still 150 CVEs, which have a possibility to impact the JDK itself. That's a problem. If we continue 17, already 69, if you stick to 17.0, and then 21, 12. But you see, with this new release cadence, if we take a look at, it went back. Can I go back? Yeah. If we take a look at the critical ones, 8 had a lot of critical ones, right? That's the old stuff with lots of features in it. Then 11, just a few. 17, so far, there's no critical one. 21, it's nothing. And there's only medium and low.
They haven't been around that long.
Yeah.
Exploits figured out.
Yeah, so but it's getting better and better over time, right? Because yeah, we will see what happens. I agree. But with the new release cadence now every 2 years, there's not that much time, but especially for 21 and 17, we will see how it is in 10 years, right? So we don't know yet. And this is based on the NVD, right? I just wrote a little, I have an API that gets the data from the NVD, and this is just a website that I can just call and it will show me all the stuff. All right. So if it ain't broke, don't fix it. Well, if it ain't broke, at least keep it up to date. And this is that's easy, it's free, and it doesn't really take long to install an update. It absolutely makes sense. And you should do it. Also on your development machine, makes sense to do that. All right. Now let's take a look at modular runtime images. That's what I mentioned already before. There was the JPMS, the Java Platform Module System, and everybody said there's at least JDK9 installed. That means we all use that, right? It can be used to reducing risk by removing modules and J-Link. Who knows J-Link? Cool. First time. Because I always ask that at conferences, and there's really a lot of people that never heard about it. And it's in there since JDK9. It comes with a JDK, and it's made to create a runtime that is tailored for your application. And so we can remove unused modules, means we reduce the risk for vulnerabilities, because there might be a vulnerability in, let's say, the desktop module, but you don't use desktop, so you're good to go. Okay. And hackers cannot attack what isn't there. Okay. So, but what is the impact? So I wrote myself a little push notification server that I use. It's actually running on my server. And, oh yeah, by the way, your application doesn't have to be modular to do that, right? It's really just the JDK that is modular. So in the push notification server, if I would use the JDK, and I was surprised when I asked at some Java user groups and conferences, who is deploying the application with the JDK? And people do that. I was like, ooh, but why? What's the point, right? These are the modules in JDK 2102, right? And you see there's stuff like desktop, that means AWT and Swing is in there. Then we have compiler, Java, SE, we have security, SQL, all these things, XML. So these are all the different modules in the JDK. And this is 69 modules, which is not the most interesting thing, but this is interesting. It's 339 megabytes. So if you deploy your application, which might be 50K, right? Then you add 340 megabytes just for the JDK. And then ask your DevOps people if they like Java. They say, oh, it's so huge. Yeah, it is. If you deploy it with the JDK, it is big because this is not meant to be deployed in production, right? This is a development kit. There is a solution for that, which is called Java Runtime Environment. These are the modules in the JRE. You see, it's not that many because we don't need Javadoc and all that in the runtime and the compiler and stuff. It's still 50 modules. It's still 150 megabytes. And with JDK9, there was some kind of, it wasn't an agreement. It was more forced on us. But there was a decision made that in principle, we as a company shouldn't really give you a JRE anymore because there's JLink. You can create your own. Unfortunately, nobody does. So we still create JREs for people and they still think, yeah, that's the way to go. I should use the JRE and add 150 megabytes, even if I don't use it. That's the way to go, right? No, it's not. Because when I use my push notification server and I used JLink, this is the number of modules that my application really needs. And that boiled down to 11 modules, and this was only 48 megabytes. And if you compare that to the JDK one, then this is the size, and the circles really representing the size of the JDK, the data that is needed to run your application. And you can imagine that if you deploy this, there's everything in there with all the vulnerabilities that might be there. If you deploy that one on the right side, it's really small. The chance for vulnerability is way lower if you use a JLink build. And you can integrate that in your build pipeline. So creating a JRE takes, it's pretty simple, right? You run JLink on your jars and it gives you a list, and then you can use JDEPs, right? Which is also made for that. It's in combination with JLink. You get a list of modules and then you can, it will just copy this stuff into a new folder. This is then your JRE, that's it. Pretty simple and it's pretty fast. Doesn't really take long. Okay. So use JLink. If you should at least take a look at it. It's pretty simple and it can really give you way smaller containers, and the DevOps people will love it because if you get down from 340 to 50 megabytes, that's a huge difference for deployment, right? Software supply chain, yeah, that was something I wasn't aware of at all. And once I took a look at it, I was like, okay, that's a lot of stuff involved here. It starts with us. We're doing the development. We drag in stuff from a central repository like Maven Central, right? Usually we do that. Then we submit in our own repositories. We build in our CI/CD pipelines. This one also drags in stuff from the central repository. And then we build containers out of it and put them in artifact repositories. This can also get back into the central repository and can also go to production. So this is more or less how the software supply chain works. You will find similar diagrams, more detailed ones, less detailed, but in principle, it's always the same, right? So this is how it looks like. And on all these places, there are vulnerabilities and there are places where people will hack the supply chain. And it's really weird hacks. So I just looked some of them up. It's unbelievable what they do. So I wasn't, for example, hacking a CI/CD build system. I was like, how should that work? Yeah, there are ways to do that. And I was really surprised what is involved here, or artifact repositories and all these things. So it's unbelievable what's possible. And people do that. So you should really make sure that the supply chain is secure and you can use tools to do that. So I found some facts, and because this presentation is a little bit older, it's not up to date anymore, but still interesting. And there's the Sonatype State of Software Supply Chain report. They always bring that. I don't know if it's once a year or twice a year, but you can look it up. And it's not all of it is free, but most of the stuff is freely available. And they found out, and that was in 2023, that the software supply chain attacks in the last 3 years was 740% increase in attacks, right? Which is really a lot. That means, yeah, people really attack all these things, right? And we have no idea. We as a developer, we write our code, deploy to the repository, bye, and then it's gone. So this is from the NVD. They also have some statistics, and this is a little bit older one. You see, it's from 2021. But in 2021, they already saw 20,142 unique bugs and security vulnerabilities. And you see, this is the chart, and then it bumps in 2017. Not sure if they changed the metric or something, because to me, it looks like, that's a little bit weird that suddenly we have this huge impact and then it grows. But yeah, this is the data you can find there. And you see, this is the old scoring, low, medium, high, CVSS 2.0. And you see, there's a lot of these high things there. So which is the critical stuff, right? And yeah, it's a bit frightening when you see that. This is something that is the worst of all. This is a user laziness. This is one of the biggest problems because it's really hard to change. I talked to Christian Grobmeier, who's one of the maintainers of Log4j. And this is that was in 2023. And he told me that 21 months after it was fixed, still 20% of the downloads download the vulnerable version. And then you ask yourself, why? What's the point? Everybody knows that there is a problem, and still 20% of all downloads download the vulnerable version. So what people mainly say is, why didn't they take away the vulnerable version? Because they don't want to break stuff. They don't know where it is used. So they say it's up to the users, right, to really make sure they download and update the latest version. But we can't just take it away because it will break things. And we don't want to break things.
What is the responsible thing to do to delete it off of Maven Central and force them to take action?
Yeah, you can argue like that, but this is usually not the way it works. So yeah, but this is interesting. It's mainly because they forgot it's hard-coded in scripts, right? So the number is hard-coded. There is no procedure to update to the latest version. People are just lazy and forgot about it, right? So this is, but it was quite shocking. And when I did it the first time, it was 2022. This number was still in the 30s. It was 34%. And I was really shocked that still, and I talked to him, when was it? I think in the beginning of the year, and he said it still see lots of people downloading the vulnerable version of Log4j, even today. That means they open everything up for hacks, which is crazy, right? But yeah, that's the way it is. There's exactly the next slide. Transitive dependencies, because that's again from the Sonatype State of the Software Supply Chain report. Usually you have your build scripts, right? Gradle, Maven, whatever. And you have dependencies in your project. And you know, okay, these dependencies is the latest version. It's cool. It's all good. But then these dependencies have, again, dependencies, and you don't see them, and you have no idea. And they figured out that 6 out of 7 project vulnerabilities came from these transitive dependencies. That means this is the stuff in your build script, and then they drag in other parts, and there might be vulnerabilities that you don't see. That means you think, oh, I'm safe, but you're not. As soon as you build it, sometimes it happens in the CI/CD build, right? You deploy, and then the CI/CD starts building this stuff. It drags in dependency from Maven Central and transitive dependencies, and suddenly you have stuff in there which is vulnerable, but you have no idea. So this is, that was quite interesting. This is still the biggest problem that we have. There's another one from Synopsys. They also do this kind of reports. We don't have to go into the details, but they found that at least one vulnerability in 84% of all the scanned code bases that they cover. And from that, 48% contained high-risk vulnerabilities. So really a lot. And like I said, this is from 2023. So this is not really up to date anymore, but still shocking when you see these numbers, right? So that means people just don't care, or for whatever reason, why you
don't know better.
Yeah, probably, right? So this is really, yeah, that's interesting. They also have a chart, a statistic where it's related to OpenJDK or open source, sorry. So in all these scanned code bases, they found that 96% use open source software, which we can agree on, and 76% of that happen itself was open source. So open source is huge, right? And that leads me to the next point, open source, because we use it, but I think most of the people have a little bit wrong understanding. So you know what that is? It says it in the upper left corner. Did you ever read it? I mean, really read it and understand what it means? Usually you see, oh, there's a license file. Yeah, that's it. Gone. Oh, it's Apache. Yeah, I know. Yeah, yeah. Did you ever read it? I will help you. It says is provided as is, right? Without warranty of any kind. And in no event shall the authors or copyright holders be liable for any claim damages or other liabilities. That's what it says. And that's what you agree to. And what it means is, I owe you nothing. That's what it means. And you have to make clear that, yeah, I use let's say open source or Log4j, whatever you use, right? You just take it because it's so great. And in the moment where you add it to your software, you agree that it's up to you to make sure that it's secure. It's not up to them, which is one of the problems that we saw when we Log4j. Many people blamed them. Oh, how can that happen? Well, it's not their fault, right? So you can't blame them because this is how open source works. And the first time I did that presentation was in Nebraska. I didn't know. And everybody was laughing. I was like, oh, fuck. It says random person in Nebraska. Yeah. But this is really how it is. This is Log4j more or less. It's used everywhere, right? It was created by some geeks that thought it's a good idea to have a logging framework. Everybody's using it. Then
somebody asked for a feature to integrate with LDAP.
Yeah. So then there was a vulnerability, and suddenly everybody blames them, which is not right, right?
Maybe put a little bit more thought into it and had a separate artifact that uses log4j. But
there are lots of ways to do differently. I mean, it worked for a long time, right?
Yeah.
So this is and it's fixed, right? So this thing is fixed. So what you have to keep in mind that open source maintainers are not suppliers, right? You don't have any contract with them. Right? There's nothing there. You sign a contract and they are reliable. No. You just take it for free. You agree to the license, and that's the way it works, right? So that means you don't have any business relationship with them. And if you use their code, it's up to you to make sure that it's up to date and that it's secure. You have to scan it. It's not them. Right? And this is something that people often forget when they talk about open source. They like to use it because they don't have to pay. It's takers, not makers, right? This is how most of the companies work, right? We take all this free stuff because it's great. And once it fails, it's like, oh, look at this, right? So, but it's up to them. And this is a big problem that I see. And we saw that so many projects based on OpenJ, obviously OpenJDK, open source. And we have to keep in mind that this is also part of open source. Very important. So what can we do? Shift left, who knows what shift left is? And this is in principle pretty simple. It's a nice word for managers, right? They love to, shift left, yeah, shift left. Yeah. It's a pretty cool word. They have no idea what it means, right? So this is the software supply chain, right? And we have the dev part on the left side, and we have the ops part on the right side. Shift left means more of the security awareness should move to the left side of the diagram, should move to us. We should be more aware of security. That is what shift left means in the end, right? So not only be aware, but also do something about security.
It's right? Like security testing.
Yeah, everything related to security, but that we can do as developers, right? And because
you have a bigger job.
Yeah, absolutely. And there's a reason for it, because this is the effect. It's easy to fix the security vulnerability here. It's cheap. Fix it in production, it's very expensive.
Same thing with testing mistakes.
Yeah, so it's really important to start on the left side of the diagram. That means shift left makes sense. And that leads to the fact that instead of having DevOps, in the meantime, we have DevSecOps, right? Yeah, sec is for security here. So if we take a look at this DevOps loop, you know, that plan, code, build, release, this is usually the dev part of it. And then we have deploy, operate, monitor, and back to planning. So where's security in this diagram? A good question, right? Well, it's everywhere. There is no, oh, you have to do security. No, you have to do it. We all have to do security. The ops part and also the dev part. This is the whole thing. So we are now also responsible for making sure that the stuff that we do is secure. And it's not really hard to do that because there are tools that help you with this. So first of all, you have to make sure that you keep your JDK up to date. Pretty simple. And who knows SDKMon? Who's on Linux here? Okay, Mac? Windows? Okay, Windows, you're out because we don't have that on Windows, but there's something like Chocolati, I think is the name, which is similar. This is a tool that helps you to update your JDK and also switch between JDKs and way more stuff. So SDKMon is big. They can do all kinds of stuff, but they also can do JDKs and get you the latest version. It's command line only. It's on Linux and Mac, not on Windows. And it downloads and installs JDKs, right? So this is one thing. To be honest, I'm a UI guy, and I'm not that much command line guy. So I was always, because I have lots of JDKs on my machine and play around with stuff, but keeping it up to date is always not that easy. So I wrote my own tool, which is in Java. It's called JDKMon. Have to update it probably. But what it does, it supports all the JDK distributions out there. So all the 20, even GraalVM. And then it downloads the JDK. It doesn't install it. And it runs in the background. It sits on your menu tray. It works on Mac, Linux, and Windows. And it just tells you when there's a new update available. That's all it does. Because I was too lazy to always check the websites if there's a new version. That's another thing. We have all these different distributions. It doesn't mean that all the distributions have the updates at the same time. Sometimes some distribution, it takes weeks until they get out with the latest update. Others came up within hours after the official update. So it depends, right? Yeah, as already mentioned. And it also shows CVEs in OpenJDK, because this is the stuff that I used for, and that's how it looks like on Mac. So it tells you the versions that you have. So first of all, the distribution. So GraalVM community, then all my Zulu JDKs. And then you see I have Zulu bundled with JavaFX. And then you see, oh, there's a new version available here, right? I can download directly tar or zip. And then you see the red exclamation mark. And that means there are CVEs for this one. This is not really secure. And then I can click on this and it tells me, oh, these 3 CVEs are open for this specific JDK. Yeah.
Does the JDKMon update anything?
No, it gives you the opportunity to download the latest version. So it tells you, oh, there's a new version, right? So this one was 16.01. It tells you there's 16.02+7. And then you can download it, and you have to install it on your own, because I didn't want to really, because I keep my JDKs, every JDK in the same folder. And I rename, the folders is for JDK 17, it's always JDK 17. Doesn't matter which version is in there, because my tool tells me which version it is. So, and with this, I only have one folder for JDK 17, one for 21, one for 23, and so on. Makes it for me easier, because otherwise you will get for every JDK a separate folder. And I really don't need all the versions. I only need the latest one on my machine. That's the reason. And this is also the reason why I don't really want to install all that. It adds a lot more stuff to do. So this is just a tool that reminds me on, oh, there's a new version. You might want to download it, right? That's all. You have static code analysis tools. That's usually part of code reviews. They identify vulnerabilities in source code at the implementation phase. So very inexpensive, right? Because you can easily adjust it. And it's standalone tools or IDE plugins. And this is the list that you can get from the NVD site, from the NIST.gov. This is not the list, it's a list, right? And that's what they explicitly say. So they say, here are some of the security analyzers that you can use. And they say it's not a complete list. It's just to give you a starting point. You see there are some free ones, some ones you have to pay for, like find security bugs. This is quite popular. It's find bugs that might resonate with some people. Find security bugs is just a success of it. So yeah, it's based on spot bugs, free of charge, blah, blah, blah. More than 400 bug patterns. It's a plugin for your IDE. So what it does is you run it, you install it in IntelliJ. for example, or Eclipse or whatever IDE you use, NetBeans. And then it just tells you, oh, in this code, there is a problem here. And you might want to fix it, right? Stuff like this. This is what it says. Well, it's quite useful. Then there are vulnerability scanners, which is way more powerful because what they do, they detect vulnerabilities either using a database or they can even probe for common flaws. So they know how to crack code and they will do it on your code, right? And some of them, and will show you the problem. So they can also monitor misconfigurations and coding flaws. They can help you using artifacts only from reliable sources. So that means if you download a library, and some people download it from some private website because that's the latest version, right? Yeah, but might not be really secure. They know which is the secure source and download it only from there, right? From reliable sources. They also can make sure that you only use the latest version of libraries, and they can even update that automatically for you. Monitor appearance of new packages with fixed vulnerabilities, so they can tell you, oh, there is a new version of this library or this framework. You might want to download it. They can even update dependencies in your build script for you automatically. And they work on all these different places, like they can scan and fix source code, scan, fix, monitor repositories, the CI/CD systems, artifact repositories. In production, they can monitor. The problem here is usually this is based on agents, right? And who knows what a Java agent is? Yeah, that's interesting because if we have the JVM, which is like a black box here, then it's, of course, it's not, right? It comes with class loader, subsystem, JVM memory, execution engine. And then it also comes with an API. Every JVM has an API. It's a so-called instrumentation API. And that means at runtime, you can talk to your JVM, right? And therefore you need an agent, which is a Java program. And it comes with specific methods. And then what you can do with a Java agent is you can add callbacks to specific parts of the JVM. For example, the class loader subsystem. So it means we can add a callback to the class loading subsystem. And every time a class is loaded from the JVM, it will trigger the callback and tell the agent, I loaded a class. Well, the problem is if you do that in the wrong way, and usually most of the scanners really just try to get as much information as possible because it makes sense, right? That brings down the performance because that happens at runtime. And that means the JVM not only has to run your code, but it also has to serve the agent with all the information at runtime. And that brings down performance. Usually it's 10% or more, the performance hit. And this is the reason why nobody's scanning stuff in production, right? So even the scanners that are available, like Sneak or Sonatype, they don't offer you production scanning because of that, because they know if we have to do it, it will have an impact on performance and nobody will buy it, so we just don't offer it at all. And these are scanners that you can find. Yeah, we also have one. And you see there's Black Duck, which is quite popular. Sneak, SonarCube, there's some more popular ones. And most of them are free and non-free. So you get a free version that can do parts of it, and then you pay for more. Also, it's not free, so because it is a little bit specific. So if we take a look at Sneak code, just a short example, it's, yeah, like I said, free and paid version, supports 9 and more languages. And it has this developer-first approach. So it means it's for us. They live this shift left thing, right? They try to address developers and not the DevOps people. They also offer this stuff, but it's specifically made for developers, which makes it quite easy to use. Also available as an IDE plugin. They have CI/CD integration. They don't have production support because of the reasons that I told you. This is now for JavaScript because they offer lots of stuff. Not important what it shows. They show you where's the problem and what is the problem, right? They give you some information about it, right? So they tell you, here's the problem and this is the actual problem that you would like to fix. SonarCube, very similar. They even offer more languages, 30 plus. Huge list of analysis rules, standalone and plugin. They also do up to CI/CD. They also don't offer something for production. Yeah, hard to read, not important. Again, where's the problem? What is the problem? And why? Right? This is what they do. So they give you all this information in your IDE That means it's really easy for us as a developer to fix these problems, right? Because they directly tell us. And now I have to tell you this one because this is our own and this is different from all the others because we saw this problem that nobody's scanning in production. So we created a vulnerability scanner only for Java and everything that runs on the JVM that only runs in production. So we don't really run in all the stuff before that. So it's more an add-on as a replacement, right? Because there's nothing else. So yeah, like I said, we run in production, staging, and testing. So everything where you're running JVM is. And it's JVM only. So whatever you use, Kotlin, JRuby, everything that runs on the JVM, we can monitor. And we have the advantage that we have less false positives. And the reason for that, I will show you. And we don't have a performance overhead. We also use an agent, but we stripped it down because we only need specific information, not everything. So we can, I think it's around 0.2% performance drop that we see. So it's not really a lot. It's part of Intelligence Cloud, which is one of our products. The interesting part is this is the web UI. We tell you where's the problem. So this is the libraries like Netty here, for example. Then we tell you, oh, this is vulnerable, and we tell you the CVSS score here. And then the new part is we tell you if it is used. And that's the big difference, because we can tell you, yeah, you have a problem. There is log4j in your dependencies, but you don't call it. That means you don't have to look it up, right? For your people, you can more focus on the stuff that is more important. Right? This is the difference with the vulnerability detection that we offer. It's more like an add-on to the others. Okay, so software supply chain that is secure could look like this. So you have, for example, third-party libraries like Log4j and Spring, and you have even complete products that are based on Java, which is quite interesting. There's a so-called Kafka Summit. It's a conference, right? You will be surprised. We had a booth at Kafka Summit, and then people approached our booth and they asked us, what are you doing? So we said, we do Java. Yeah, but this conference is about Kafka. Say, yeah, but Kafka is running on Java. No, yes, it is. So they had no idea, right? So that means these people just use it without really knowing or caring because they don't know that it's using Java under the hood. Yeah.
But I know it runs with Java.
Yeah, you should know. So then you can use code scanners like Sneak, Coverty, or Contrast, and also use it in CI/CD. And then you can use Anchor, which is for container scanning. And you can use Azure vulnerability scanning for production scanning only. So, and with this, you can make it secure. And this is all the shift left approach, right? And the idea is these tools tell you what probably can go wrong. And we can tell you if they are right or not, right? Because they give you a huge list. And with the other data, we can filter it down and say, okay, but this stuff is the only thing that you used. You don't have to check all the other stuff yet at the moment. And the biggest problem, because we had some customers with that. So what happens is sometimes you have a framework, right? And that framework is still based on an older library that they need, right? And this library might have a vulnerability. So what happens, you rely on this framework. Your vulnerability scanner says red flag. You can't deploy to production because there is a problem. You know it's not used, but the scanner still says, no, this is red. I see it, but you know, but we don't use that stuff. And that sometimes is a problem because then you have to talk to the DevOps people that do the deployment and say, nah, it's okay. We know that we don't use it. We checked it already. And then you have to check it again, right? With the other approach, you can prove, okay, it's really not used, right? So the takeaway is that you should follow an automatic patch schedule. And usually you should do that with the OpenJDK vendor updates. So that means in January, April, June, September, you can check if there's a new update, do the patching directly after the update with a new version. That's quite important. Try to create your own JRE with JLink. It's absolutely worth it. I don't know why nobody's really doing that, but it's so easy. I have a script that does it. So it's really, you can add that to your build script and it will just create a JLink, use JLink and create a JRE for your application. Pretty simple. Yeah, watch for CVEs and libraries. Helps a lot. Be aware, right? And use vulnerability scanners. Most of the companies use it, but I saw that as the smaller the company, the less is the awareness for security. Bigger companies usually are more aware about security, but smaller companies usually it's like build now, fix later. That's their approach, right? So do you need to be a security expert? No, but you need to be aware about it. That's the takeaway from that session. And with this, yeah, stay secure. And thanks for listening. I hope it was somehow interesting. Now I have to stop sharing, right? All right.
no audio, so. And thank you so much. I really appreciate it. That's such a useful presentation. And let me go ahead and stop the recording here.